So we have three major features in Flexcom 8.4. So I'll go. There's a feature then that overarches all of that, which is the improved help. Okay, so I'll just show you that. So in previous versions of Flexcom, the help was first of all, we had printed manuals, and they were distributed in the post. Then since we moved more modern to PDF documents, and in this version we made a step change again to online help, or help that's built into the program. Okay, so it's integrated in that all the theory and the theory and the syntax is all within the program. So previously, in previous versions of Flexcom 8.2.3, 8.3.2, we had the documentation for the syntax available when you press F1, for instance. So now the theory and all the examples, all the help is available through this interface. It's fully cross-linked, so the syntax, so any of the keywords and the table syntax is now cross-linked with the theory. Okay, so that makes it a lot easier to browse. So if you're looking at a particular feature in the theory and you want to know how to implement that in Flexcom, you just click on the relevant keyword. Okay, and it's online. So a lot of the things that you might be searching for in Flexcom or want to know how to do in Flexcom, you can now find even through Google. So if you just search for the phrase in Google, you'll likely find our manual online. Okay, so you'll find this blue eye symbol on each of the slides in this presentation, or at least most of the slides in this presentation. And if you click on those, you'll be brought to the relevant help section online for that particular feature. I'm going to send around these slides in a PDF after the meeting, so you'll be able to click on those symbols yourself if you want to find information about each of the features. Okay, so I'm just going to click it here now just to show you what happens. Okay, so it just goes to www.mcskenny.com/support/Flexcom, and you're brought to this interactive documentation. Okay, so it's structured logically. You've installation instructions, instructions about the user interface, the data inputs, previously known as the online help. So I'll just show you that. So you'll be familiar with these keywords, dollar model keywords, say for star element. Okay, just like that. Star element. Okay, I picked one that isn't working. But yeah, so star elastic surface, for instance, you click that, and then you can click refer to Stephen interaction for further information. And that will refer you back to the theory section for that particular feature. Okay, someone has just joined here. I'm going to mute them just so that there isn't any feedback. Okay, so back to the presentation then. So that's the online help. So that's available. Yes, that's available from within the program as well. Okay. If you go to help, manuals, and then you'll get all the same sections here. So I go to Flexcom, for instance, and that brings me to the root of all the help. And then I can navigate as I normally would through the different sections of the help. Okay. So resume here. So that's the help, and that kind of touches on every feature in Flexcom 8.4, and it kind of improves everything, just making things easier to use. So the first then of the three major features I'm going to talk about is unit awareness. Okay, so if previously Flexcom was not unit aware, the user had to be careful about what units they were using as inputs, and make sure that the results they were getting made sense. Okay, so now when you specify, so there's an option now in Flexcom with two new keyword file extensions. So we've always had keyx, so now we have keyxm and keyxi file extensions, and they indicate metric and imperial analysis. Okay, so all these do is tell Flexcom explicitly that the base units for the analysis are either metric or imperial. Okay. For the keyx files that you're used to, there's no change. Okay, so I'm just going to go into more detail now in the next slide about what that means. So this is if for a particular analysis that I was doing. This is a screenshot from the table view, and then below it's from the keyword editor. Okay, for this is a keyxm file extension, and you'll see in the table header that I have my base units in metric explicitly stated in the header for me. So these are the units that Flexcom is expecting for the analysis, and they're consistent. Okay. To have a consistent analysis. So you see that your bending stiffness is in Newton meter squared, your axial stiffness is in newtons, your mass is in kilograms per meter, and all your diameters are in meters. Okay. You'll see also in the keyword editor that the units that if I hover over any of these sections, so I'm hovering over a bending stiffness here, that it's telling me the units are in Newton meter squared. Okay. I can override these also, and I'll show you that in the next slide. Okay, so that's just saying what the base units for the analysis are. So this is when I explicitly specify a keyxm file extension for my keyword file. Okay, so another application. So this is a sample data sheet for a drilling riser. Okay, and you see your stack up on the left. Various components that you might have on your drilling riser stack up, and then the length of each joint, the outer diameter and the inner diameter. Okay, and typically manufacturers will specify these parameters in different units, so it might make more sense to have the length in feet, whereas the diameters are smaller, so it makes sense to have them in inches. And rather than have the user try to convert those themselves and go to the hassle of doing that, Flexcom will now make it very convenient for you to do that. So if you use this angle bracket notation, so I'm using open angle bracket, 21 inch close angle bracket for my outer diameter, okay? So that tells Flexcom that I'm actually inputting 21 inches and not feet, as would be suggested by the header in the table, okay? Flexcom is very flexible in that it'll take the word inch, it'll take in, it'll take inches, and it'll even take a double quotation mark. Okay, for every other unit type, it's similarly flexible, and it doesn't really care about spelling. And if it's not able to recognize something, it'll tell you by underlining it in red. Similarly, in the keyword editor, you'll see that I'm specifying angle bracket 21 inch close angle bracket. So this is obviously a keyxi file extension because I have imperial units in my table header. If I could equally put in 21 centimeters here, and it would be converted to the equivalent base unit in feet for me behind the scenes, so I wouldn't need to worry about it. That's just saying if I had a metric diameter, I could input that in an imperial file with a keyxi file extension. Okay, so again, any more information that you need on these things, just click on this I symbol on the PDF that I'll send you after this meeting, and you'll get more information that way. Okay, so that was input. You can also post-process your output into any units. Okay, so similarly, this is a snapshot of a table view and a keyword editor. And you'll notice there's an extra column unit and an extra tag here, units equals. Okay, so what that tells Flexcom is the units that you want the output in. So if I'm doing a metric analysis, I can specify units equals kips, and I'll get a plot with my force in kips rather than newtons. So by default, you'd expect to get your plot in newtons because that's the base unit for force. But I can override that and specify my units as kips, or equally units equals kilonewtons, if I want to apply a scaling to the output. Okay, so that's very handy, and that works. So that, as I said, that works if I have a metric analysis and I want to post-process in imperial, or vice versa. So it's quite flexible in that regard. Okay, so Uh, the unit awareness extends into the output files also. So each of the headings now in the output file will have the associated units underneath them. Similarly, in the Excel output file, you'll see your units in the table as well. We have a handy tool if you want to migrate a large project to employ the new KeyXM or KeyXI files. So all this does is change the extension of your existing keyword files with the KeyX extension and changes them to either KeyXM or KeyXI based on the value that you select in this drop down here. So you give it your input directory, you specify what the output directory is, and it'll copy all the files across and simply change the extension. The onus is on you, obviously, to make sure that the values within those files are either metric or an imperial system. A mixed system obviously wouldn't work with this. You'd have to go and do some more work to edit that. Okay, so that's the first of the three major features. The second one I'm going to talk about is the model view. Okay, so with every version of Flexcom we try to do a lot of work on the model view, and this version is no different. So the first thing you'll notice is that the rendering is a lot brighter and sharper in this version. Okay, so just showing you a screenshot here from Flexcom 837, and you'll see that the arch is made up of two buoyancy canisters, and that the edges of them are kind of jagged. Okay, so in Flexcom 841 then you can see that they're perfectly smooth. Everything is just a lot crisper and sharper, and so any screenshots you do for reports or whatever will look a lot better. So similarly then, this is just another example of you'll see it especially on elements with large diameters such as buoyancy tanks. So this is a particular buoyancy tank, and you'll see that the shading is a lot better. There's a larger number of surfaces that make up the circumference of this shape, so that it's a lot smoother. You'll also find that in older versions of Flexcom, the buoyancy tanks that you used tend to rotate, but this was a kind of a phantom effect. They weren't actually rotating. It was just a phenomena of the number of sides that were used to render the shape. Another little small feature, so if you look at the 837 model view, where you have fairly large diameter elements going around a sharp bend, you'll see that there's little gaps between the elements. So in Flexcom 841 we just added little wedges between elements, between cylindrical elements, to smooth that out and make it look a lot nicer. One of the big additions we made in 832 was to add stress contouring. So this is where you can look at the model view, look at your animation, and see the various stresses or forces on your system in different colors, green to or red to blue, green in the middle. So an improvement that we made for 841 was we allowed users to specify the range for the coloring. Okay, so previously the Flexcom was calibrated based on the min and max force or stress that was experienced over the whole elements or the whole structure. Okay, so that might not make sense if you're in that. If someone that wasn't familiar with the model was looking at it and they saw things were red, they might assume that something is critical or is close to failure at that point. Okay, so we added in custom stress ranges, which you can specify a min and a max, and you might want to specify your max as being the limit or yield of the material rather than just simply the max force that occurred during the analysis. Give you more realistic coloring for your animation. And a small nice little tool is the ability to measure in the model view. So if you select the measuring tape from the model view toolbar and you click and drag anywhere in the model view, you'll be able to get a rough distance between any 2 points in the model. So that's very useful to quickly interrogate distances in your model. So that's in addition to the scale indicator that we added for 832. Okay, so we can also do multiple viewports. So this is an example showing 4 viewports in the one window. Okay, and if I press play, all 4 viewpoints will move, will play back in sequential, or what's the word, in sync together. So I'm looking at the response of the buoyancy tank in one. I'm looking at the overall system in another. I'm looking at a particular riser in another. So I can see the whole system with my 4 viewports. I can also have 2, 3. I can customize it so that there's either 2, 3, or 4 different viewports on the screen at the time. Another thing that people were asking for through feedback was the ability to move between different camera positions quickly. Okay, so if you're on a laptop, it might not be easy to navigate quickly to various parts of the model that you might want to show somebody. Okay, so on the toolbar now, you'll see this camera icon, and if you click that, you'll get this new dialog. You can, so the way you'd use this is you'd first move to the position in the model where you want to save a camera position. Then you'd move up and you'd click this camera icon. You give the camera a sensible name, and then you click the save button. That camera position is then added to the list, and you can double click it or click the restore button at any time, and the view will snap back to that camera position. So it's useful for storing a number of camera positions around your model. So one of the big features then in the model view was the addition of a element inspector panel. Okay, I'm going to give you a demo of this, but just to look at the screenshot first. You see that I can click, if I hold down the control key on my keyboard and click any element on the model view, I will get this element inspector panel populated with the information for that element. Okay, so I can see that the element name that I've picked, the start and end node. Okay, I'm just going to give you a live demo showing you how that in action. Okay, so I have my model view here. I'm going to open up the element inspector. So I'm just going to dock this alongside. Okay, if I zoom in now on a particular element, say I'm interested in this element here, I hold down my control button and press click. You can see that the element is selected in the model view. And also I can see that its element 396, its start node is 398, its end node is 399. It's a member of the oil jumper geometric element set, and it's a member of the all hydrodynamic element set. I can see its length, I can see its diameter, I can see its flexible stiffness, its bending stiffness, and its all its structural properties, its stress properties, and its hydrodynamic properties. So that's extremely useful if you want to interrogate a model, QA a model, just to understand how a model is set up. I can also use this drop down to search for named elements in the model, and it'll quickly zoom. So I can see that as soon as I change this, the element is selected in the model view, and I can see the properties for it in the element inspector. Okay, so that's a really powerful and useful feature when you're looking at a model. Okay, it looks like I'm after losing my place in the presentation, so I have to go back to it again. Okay. Another small feature that we added was, so you've always had the ability to view node labels and element labels. Now you have the ability to view set labels. So that's invoked using this checkbox element sets. Okay, so that gives you a quick snapshot of the layout of a model, and I find it very useful when I'm looking at a model that I'm not familiar with, to quickly see the layout of the model and the structure of the model. Okay, so I can see that my riser is here, my wellhead is down here, my 36-inch casing is down here. So it just gives you a very quick snapshot of how the model is structured. Okay, so that's the second of, oh sorry, the second of our three big features. And the last one then is a 3D seabed. Okay, so in previous versions of Flexcom, we've had a flat seabed, we've had a sloping seabed, and we've had a 2D arbitrary seabed. Okay, so in Flexcom 841, we've added a 3D arbitrary seabed. Okay, so this allows you to input a completely arbitrary cloud of points. So this might be a text file with X, Y, and Z coordinates for a number of different points, as many as you need. Okay, you feed this into this small utility tool, and from there Flexcom will take that, it'll triangulate it, create a mesh, and perform linear or cubic interpolation options on that to give you either a jagged or a smooth analytic surface for your seabed. Okay, so you see a small snapshot of it there on the top right. I'm going to show you a video now. I hope you can hear the sound showing you the 3D seabed in action. Just incidentally, if you have a few minutes to spare, we have a lot of videos on YouTube these days, so if you do a quick search, you'll find them, and you might find other features that you're not familiar with that are in Flexcom at the moment. So I'd recommend checking that out. Okay, so I'm just going to play this now.
This video illustrates a pipeline installation scenario modeled using Flexcom. This is a complex installation procedure as the pipeline is laid down over a steep subsea precipice. The wedging process is modeled using Flexcom's wedge element feature, which allows paying out or wheeling in operations to be simulated. Flexcom uses color contouring to graphically display element forces, such as effective tension or bending moment, and this provides the engineer with an intuitive visual representation of the finite element results. Flexcom possesses a powerful seabed modeling facility, which can handle complex topographies with ease. The user simply specifies an arbitrary cloud of data points, and Flexcom's triangulation algorithm automatically generates a continuous seabed profile. This generic data input format offers complete flexibility and means that Flexcom can readily accept seabed data from a range of third-party software.
Okay, so you can see from that video that it's a very powerful feature. You can see that as the pipe was being laid, it was adjusting and moving to fit the 3D surface. I'd recommend that you check out the installation example that ships in Flexcom 841, and that's where that video was taken from, and you'll be able to run that and look at the model for yourself and check out the new 3D seabed. Okay, so that's the three major features. I'm going to move on now and talk a little bit about some of the smaller features that are in 841. Okay, so the first one that users will be glad to hear is that we've increased the analysis throughput. Okay, so what that means, so in recent years or in the last number of years, the onus is for more and more analysis to verify designs. So you're doing more and more analysis than you were this time 4 or 5 years ago. Okay. So in Flexcom 841, we've made a commercial decision to double the number of cores as standard. Okay, so previously there was a 2-core license, and now that's been upgraded to a quad-core license as standard. So in the time it would take you to do 2 analysis, previously you'll now get 4 done. Okay, so it's a free upgrade to all users. So that should improve your productivity a lot. Further improving your productivity is runtime performance. So we've now switched to, we make a 64-bit version available of Flexcom, and I recommend that this is the one you install if your system is compatible. 64-bit refers to the amount of memory that the program can address. Okay, so this is especially useful for large FE models where we need to hold a lot of information in memory. Excuse me. Similarly for post-processing, be it statistical or fatigue post-processing, again we're holding a lot of information in memory and we need to process that to come up with statistical plots or fatigue lives. You'll also find that the 64-bit version, or at least I find that the 64-bit version of the model view is a bit quicker and it's smoother than before. for large models. Excuse me. You'll notice that the analysis is 15% faster than before. So on the previous slide, I said that, excuse me, my voice is going here, sorry. So on the previous slide, I said that there was now 4 cores where there was previously 2. So for each of those 4 cores, or for each analysis on each of those cores, each of them are now 15% faster. Okay, so to put that in context, we're always trying to improve the speed of runs on Flexcom. So that's 30% faster than Flexcom, the first version of Flexcom 8, and it's over 76% faster than the previous 7.9 version. Okay, so improving runtime performance is something that we've been committed to, and that's something we're going to bring into the future as well. And we've reorganized all the examples that come with Flexcom so that hopefully they're more intuitive and more easy to navigate. Okay, so you'll see on the left that if you click on the help and examples, so on the main toolbar in Flexcom, if you click help examples, you'll see this toolbar here, and you'll see that there's examples A to K organized, and there's sub examples within those. So some of the new ones I've mentioned. We have a pipe laying example that's H4. That's the one I recommend if you want to look at the 3D seabed. E3 is a floating hose example. J2 is a database access routine, and in that you'll get fully ready to use VB.NET and Fortran projects. They can be used if you want to extract information from your database, for if you want to do further post-processing or write your own scripts around that. And finally then, example C3 is a turret disconnect scenario. Okay, so that's just 4 of the new examples. I think there's 5 or 6 new ones in Flexcom 8.4, so check those out. Another new feature that we've added in Flexcom 8.4 is solution criteria. So this feature was brought across from our sister product, PipeLay. So this feature allows us to vary, to achieve a tension, hang-off angle, or bending stress criteria. So that's just 3 of, I think there's 8 available: axial stress, axial strain, bending strain, etc. So we can achieve any of these criteria that we set by varying either vessel position, line length, or node position. Okay, so I'll give you more details on that now. This is an animation or a playback of Flexcom's attempts at satisfying a hang-off angle criteria by varying the vessel position. Okay, and you see as I play this, you'll see Flexcom moving the vessel position in order to achieve that hang-off angle. Okay, so it converges once the hang-off angle has been achieved. So how this looks then in the table view for Flexcom. So I've said that I want to adjust the FPSO position, and I want to adjust it along the vector global Y, which I've defined previously. So that's just a 2D vector in a direction in space. I've said what the criterion type is. So I want to get a particular hang-off angle. I want to get the hang-off angle on a particular element, and the value of the hang-off angle I want is 18.52 degrees. Furthermore, you may want to select this print options output. It's an optional entry in the keyword, but it'll make Flexcom output all the solution criteria details to the output file. So the steps that it took to get to that particular criteria, to satisfy that criteria. You may want to include more than one criterion in a given analysis, and they're attempted in the order that you specify them in the keyword file. So that's a big feature, another big feature for Flexcom. Shear 7 is now fully integrated into Shear 7. So this is invoked through the $Shear 7 section, which is a new section in Flexcom. Okay, so in the $Shear 7 section, there's a whole raft of new keywords. They basically specify the information that you'd usually put in your Shear 7 DAT file. You'd have to put this in manually. So Flexcom now, through Flexcom's automation features, you'll be able to generate these files automatically. So for instance, you might have 100 different current load case files, and you could stick in this Shear7 section at the bottom of each one, and as soon as you run each of the 100 load cases, Flexcom will automatically take that and run a subsequent Shear7 analysis automatically for you. Okay, so that takes a lot of the strain out of running your Shear7 analysis. So yeah, so behind the scenes, Flexcom is generating the DAT files and passing those to Shear7. Okay, so we also have soil models in Flexcom now. So previously, the user had to specify their PY curves explicitly. So we have predefined sand, soft clay, and stiff clay models now in Flexcom. So by varying a number of different parameters in those models, Flexcom generates the appropriate PY curves behind the scenes for you. Okay, so more information on these various soil models can be found by clicking this I symbol, which will bring you to the online help for soil modeling, and you'll be able to see what models we've included in Flexcom, the details of those. We've increased the types of code checking that we do in Flexcom. So we now added API standard 2RD. That's in addition to DNV F101 and DNV F201, which we had previously. Okay, so that increases our code checking abilities. With every version of Flexcom, we improved the table editor and the keyword editor. So in the table editor, you'll notice that there's a new undo, redo functionality. So previously that was only available in the keyword editor. So we have new drop-down lists. So wherever there's an entry where there's a number of inputs to choose from, for instance, your set names, that'll be now populated in a drop-down. So clicking the down arrow here, you'll be given a selection of various set names without having to type them out. So once they're defined in the model, they'll appear in this list. Also, the visuals have been cleaned up and improved. Similarly, in the keyword editor, we have a new font, so that makes the keyword editor look a bit fresher. Small things like zeros now have a diagonal line down through them, so they won't be mistaken with O's. We have parameter highlighting. So if you look in this example here, you'll see that I have a number of parameters. I have 3 parameters defined in my $preprocessor section. And if I look in the model section, that these are highlighted in bold and blue. So they stand out and they're easily identified in the model. So it makes it quick to QA your model. We also have Smart Select and Quick Find. And I'm just going to switch to Flexcom to show you those. Okay, so can I make this a little bit bigger? Font size. Okay, so it's a little bit bigger now. If I double click or if I select any text, all instances of that text are now highlighted in the keyword editor. So I think that's a really useful feature for me anyway, when I'm making my models or when I'm looking at models that I'm not familiar with. I can double click or it just makes finding element sets, finding curve names, finding element labels, all the things that you'd be looking for, makes them very easy to find within your keyword. Similarly, if I press Control F for find within the keyword, as soon as I start typing, it'll start highlighting all instances of that search term as well. Okay. We also added a data preview. Okay, so if you have your curves defined for, say, a nonlinear material or for your PY curves, for instance, it's kind of difficult to see those in Flexcom without copying the data and pasting it into Excel and plotting it there. So in Flexcom 8.4, we've added a very handy input value graphs panel. Okay, so if you were looking at the input value graphs panel and you clicked into this keyword, you'd immediately see the curve that you added to that keyword plotted in the panel. So it makes it very easy to QA your model and to look at that curve. Okay, no, that's fine. Um, and then another feature we've added is set length time traces. Okay, so under start time trace, there's a new option, type equals length. You type in, you give it a set name, and it'll then plot the length of that set over time. So this is very useful for, say, installation analysis, where you might have a winch set, and you want to monitor the length of that winch over time. So this is just a screenshot from an installation where there's two winches, and you can see the two winches and their length over time. Curved guide surfaces was something we added in a previous version of Flexcom. I think it was 8.3.2. So this allowed you to have a riser or mooring line or whichever in contact with a curved guide surface. So where these are used predominantly, in my experience, is in modeling mid-water arches. So if you look at the mid-water arch that we have in Flexcom 8.4, you'll see that the top surface of this arch is modeled with these curved guide surfaces. So the problem with those up to now has been that you can only model contact with the convex surface, or the outer surface. So in Flexcom 8.4, we've added an option for the contact with the inner surface also. So this might help you to model things like chutes, or say in this example, a diverter housing on a drilling riser. In terms of getting output from the program, we've added a CSV output now. So if you want to so often you'd want to look at your data in Excel, the plot data, for instance, in Excel. Up to now, you've had to right-click on each plot manually and export to Excel individually, each plot. So you can now add an option under star output files in your $database post-processing section. And it's just simply CSV equals yes. And what that will do is create a CSV file to accompany every plot file that you've requested. Okay, you can look at these or not. They'll just be generated if this CSV equals yes is specified. If you double click one of these CSV files, Flexcom or Excel will open automatically, because it just stands for comma separated variable. It's a standard format. And on the right here, you'll see, if you double click, you'll open it in Excel and it'll look like this, just your two columns of data. And if you were to open it in a text editor, you'll see just the two columns with a comma in between like this. So it's very useful if you want to parse your data again, or to perform some sort of further post-processing or plotting with the data. I think this is the last of the small features I'm going to talk about. Variable plots. Okay, so previously we had variable plots in Flexcom, but I think they were difficult to use, and also you weren't able to do things like have angles as one of the variables. So now we've kind of generalized it so that in each of your time traces you have this optional ID equals tag. So you give it some sort of unique ID. So here I've given it tension and angle, and then under this new type equals variable, I can use these angle and tension IDs again, and that'll generate a new plot, a force angle plot, just like this. Okay, so that runs through all even the small features. What's on this slide is miscellaneous features, so they're very small features. So PIP penetration warning, that it's a thing you can turn on if you want to check that your inner and your outer pipe have penetrated each other, or it might indicate that the stiffness of your PIP connections isn't large enough. So that's just a warning you can switch on. Run root if you want, in addition to run branch if you want to run analysis preceding a particular keyword file. It's much easier now to replace your license file. We can now support the 64-bit versions of Excel. There's lots of these here. Line locations. So if you use the star line locations keyword, you'll now get an element label before and after the new node that you've created. Force, motion, magnitude. So previously degree freedom 7 on your plots was reserved to get the magnitude of the rotation. So the magnitude of the degree freedom 4, 5, 6 vector. We've added degree freedom 8, which gives you the magnitude of the translation vector, the degree freedom 1, 2, 3 vector. Okay, so that's just a small thing. You'll find again you'll find these in the help. We've added a demo version to give new users an experience of Flexcom. I think, yeah, that's pretty much the end of the features in Flexcom. On behalf of all of the development team, I want to thank you for all your feedback and your support over the development. A lot of the feature suggestions came from users, so thank everyone for those.